Next speaker, that our second topic will be what are the latest trends in science investigatory project? This is to be discussed by our second speaker. He he got his Bachelor of Science in Mathematics and Science Teaching with a major in chemistry at University of the Philippines, Los Baños on 2016. He's currently studying Master of Science in Biochemistry, minor in Molecular Biology and Biotechnology at University of the Philippines, Los Baños from 2018 up to present. He is a licensed professional teacher. His research interest, biochemistry and protein chemistry, nanotechnology, especially on green synthesis of nanoparticles, and phytochemistry. So he was a teacher consultant in research on junior high school grade 10 and also a teacher consultant and final defense panelist in research of senior high school grade 12. So let us welcome him with a virtual round of applause. He is our guest lecturer, Mr. Joffrey Dallas Reyes.
Hi, okay. Good morning sa lahat. Okay po, good morning. Good morning sa ating mga students from Lipas City Science National High School, especially to the principal, Ma'am Villanueva, and also our colleagues in Batangas State University, and also to our dean, Ma'am Matilda Timaano. So allow me to share my screen first. So, Lay, can you affirm if nakikita na ba yung slide?
Yes, sir.
Okay, so thank you very much. I will now proceed. Okay, so thank you very much for that kind introduction. So, overwhelming nun. So, I will be talking about the latest trends in science investigatory project. So, for the outline of my presentation, so I will also give some definition, legal basis and goals of why are we doing science investigatory project. Also, the highlight of my talk for this morning will be some of the latest trends in the areas of priorities in basic research, and also some current challenges and some possible solution in doing your SIP, especially now that we are under a pandemic. And of course, to end with a summary. Okay, so science investigatory projects are actually science-based research project or studies. So this will help you students to make real-world connections. So you make real-world connections by solving a problem. So you need, in doing your SIP, you're actually addressing and you're trying to solve a problem in your community. Another definition by Hoti is it is a science experiment that is performed in a classroom setting with a class separated into groups, but it can also form part of a scientific exhibition or a fair project or project fair. Pero sometimes, yung SAPs natin can also be done outside the classroom. You can do it, yung mga preliminary na testing nyo ay sa bahay. O kaya naman, if you want to upgrade your analysis, you can visit and consult some research institutions or research laboratories. And usually, ang end goal ng ating pag-SIP is to join a contest. So, meron tayong mga tinatawag na school level na defense ng ating mga SIPs. Then, if you get selected, you'll be sent to division, and then possible in regional, and it could also go to national level. So yan yung mga science investigatory projects natin. So bakit ba tayo nagsa-science investigatory project? So parang quick review lang ng ating constitution. So this is actually mandated in our constitution in Article 14, Section 10, especially on science and technology. So let me read the Section 10, first two sentence only. So science and technology are essential for national development and progress. So the state shall give priority to research and development, invention, innovation, and their utilization. So that's why we are doing an SIP. So ini-encourage tayo ng ating state, ng ating estado to do some research. Why we do some research like this? Because we want to contribute to the development of our country, especially in the science and technology. Also, there's a law here that um, that's that is Republic Act 2067. So this was the Science Act of 1958. So 1958 pa, ang tagal na. So okay, so 958 yung act na to, and this is the basis kung bakit meron tayong mga research fundings. Okay. So why do we conduct this SIPs? Of course, we want, if we are your teachers, we want to develop your scientific investigation, your scientific mindset. So having a scientific mindset, you can do this process. This is actually your scientific method. In the end, we want to develop you students as scientific person. Parang ano kayo, scientist, 'di ba? You're starting to become one. So the time to yung para maging scientist kayo ay ngayon. So kaya kayo pinagagawa ng SIP. And also, para ma-appreciate nyo kung paano nag-i-impact yung ating science with the society. Also, ito yung sinasabi ko kanina na gusto ring ma-develop yung consciousness nyo, kayong mga nasa kabataan, and promote public understanding and appreciate scientific breakthroughs. And of course, we want to improve the quality of the science and technology in our country. So ito, let me share lang that in US, merong studies na iba't ibang fields. So makikita nyo dito yung trends in the submission or by subject. So in the recent years, may nakita kayo nag-spike dyan, this green one, that is for cellular and molecular biology. And yung ibang fields, medyo, ano lang siya, static lang siya. Pero gradually increasing. Pero yung sa cellular and molecular biology, napakataas nung increase niya. And later on kasi, the cellular and molecular biology fields will play a part in our pandemic. Diba? So, ina-address yung virus na to, kung paano ba mako-contain yung virus. And this one is yung Regeneron Science Talent in US. Kumbaga, ito yung nationwide nila na science investigatory project. Yan. So, napaka-prestigious na manalo sa ganyang events. So, nabanggit na to kanina ni Ma'am Angie that meron tayo ng process sa research. But the research process is actually cyclical. You first think and plan, you discover, you gather and analyze, you write and publish, and it doesn't stop there. You need to, as much as possible, you share your results. And it goes back to thinking and planning. That's why itong thinking and planning is actually the first crucial step at siya yung pinaka-importante. So it's also cyclical because it starts with a problem. Iisipin mo yung problema, poproblemahin mo yung problema, and at the end, it will give birth to another. So there's another way of looking at it na yung research process is helical. Kasi pwede yung na-research mo ngayon ay gagamitin pa ng another person na basis, kaya tayo may review of literature. So, yun ay yung tinatawag na helical nature. So, ang tanong ngayon is, do I start? So, paano ba ako mag-iisip ng topic? So, allow me to present now yung latest trends. And this could be the sources of inspiration for your possible SIP topics. So, number one na nilagay ko sa slide ko is this one, the Sustainable Development Goals ng United Nations for 2030. So, these are 17 goals that should be achieved by all nations under the United Nations. And this addresses some pressing issues ngayon sa ating planet Earth. So, you may get some of the goals here, like Number six, napaka-importante ng clean water and sanitation. So this is a problem and maybe you can do some part in the solution. 'Di ba? Sabi nga ang chemistry napaka ano niya kasi may solution lagi. 'Di ba? Tapos we can also take part in the climate action kasi we are now dealing with the climate change. It's a reality now. So kailangan nating bawasan yung ating mga emissions. So there's a need to go away from traditional na fossil fuels and use some alternative energy sources. And also number 14 and 15 yung life. So life below water and life on land. So pwede niyong ma-address dito yung pollution. So paano ba natin mababawasan yun? So this SD goals will be a blueprint to achieve a better and more sustainable future for all. So sana ma-achieve natin ito in 2030. So in the setting naman ng Pilipinas, meron tayong tinatawag na Philippine Development Plan. So yung development plan na to, this is under the current administration. So ang ini-envision naman ng ating ini-envision ng ating ang ini-envision ng ating government by 2040 is may vision tayo. Yun yung tinatawag na isang matatag, maginhawa at panatag na buhay para sa lahat. So, meron mga plans yung government natin. And vis-a-vis with that, yung DOST will always conform with this PDP, where Philippine Development Plan. Okay? So that's why we have this called your Harmonized National R&D Agenda. This one, the latest is yung 2017 to 2022. Yung old version niya is the 2013 to 2020. So, ito yung mga possible areas na pwede nyong puntahan for your SIP. So, in 2013 to 2020, these are the initial list. So, napaka-pressing kasi ng mga issues dito na sana meron tayo makontribute na research. So, para makatake part tayo in the solution. Okay. So, like for example, agriculture, napaka-pressing na issue niyan. We can also go to electronics, energy, environment and natural resources, disaster mitigation and management, especially this one. Napaka-bombarded tayo ng disaster, di ba? In volcanoes, di ba, nung recent yung Taal, yung ating mga typhoons, mga storms. So napaka-blessed natin ng mga being in the Pacific. So ang dami nating na-experience na weather disturbances and climate changes then. We also have health, manufacturing and production, information and communications technology. And this one, ito yung inaaral ko ngayon in my master's, biotechnology and of course, nanotechnology. I have a separate, mamaya may talk ako about nanotechnology. So sana ma-entice ko kayo doon. Okay. So ano ba yung 2017-2022 harmonized R&D priorities ngayon para ma-achieve yung ambisyon natin 2040? So yun nga, para ma-achieve yung vision na meron tayong malasakit at meron tayong pagbabago at kaunlaran sa ating bansa. So meron tayong 5 priority areas in National Integrated Basic Research Agenda, in health, in agriculture, aquatics, natural resources, industry, energy and emerging technology, and disaster risk reduction, climate change adaptation. So I will proceed with my next slide at dito nyo makikita yung napakadaming areas na pwede nyong puntahan. Okay, so this one is the R&D priority area. So medyo overwhelming siya pero makikita nyo dyan na yung may mga nag-overlap dyan ng mga research areas. So, ang ipo-focus ko mainly dito is itong sa part ng NIBRA, yung National Integrated Basic Research Agenda. So, eto. So, tatakpan ko muna siya. Yan. So, kasama dito yung tinatawag nating water security. So, ang ginawa ko nung binabasa ko ito, nag-iisip ako ng mga possible topics na pwede nyong gawin in your level as students. So for water security, pwede kayong mag-dwell dito in pollution control, in monitoring, in bioremediation. If you're familiar with bioremediation, ito yung paggamit ng mga certain plant species para mabawasan yung effects ng mga heavy metals. So may mga plants na kaya nilang i-absorb yung mga heavy metals, yung mga pollutants. You can also check your quality, water quality ng inyong locality, and yung impact ng humans sa water sources natin. For the second one naman is on food and nutrition studies. So pwede ditong sumama yung ating pest control management. So yung mga nababanggit ni Ma'am Angie kanina na meron tayo ng mga antimicrobial kasi maaring may effect yun sa ating mga pananim. And in return, in the long run, may effect siya dun sa ating food security. 'Di ba? If infested yung ating mga crops, so paano tayo magkakaroon ng ng abundant supply ng a particular crops. So you need to address pest control and management and also biological pollution. For health sufficiency, so under dito yung fundamental studies on potential sources of natural products and yung veterinary studies and social dimensions of health. So mag-focus na ako doon sa first. So pwede nyo ditong puntahan yung mga nababanggit na anti-inflammatory, antibacterial, antimicrobial, yung mga lahat ng mga anti-properties. Tapos pwede nyo gamitin yung mga plant extracts. And we also have here yung bioprospecting. So yung paghahanap ng mga possible plant species or mga organisms na may medicinal na na hatid o may daladalang dulot na medicinal aspect. You can also go to herbal medicine and isolation and characterization of organic compounds. Okay? So I hope so far ngayon ay meron kayong mga nakikitang mga possible topics for your SIPs. Next one is on clean energy. Pressing itong issue na to kasi yun nga we're under may climate change na tayo na experience. So ano yung mga alternatives, yung mga briquettes or charcoals from plant and waste materials na sinasabi natin na efficient yung burning at lesser yung CO2 na nire-release. And you can also dwell to other green sources of energy. And the last one is on sustainable communities. So dito naman ay yung mga environmental monitoring and environmental studies. So yung effect, like we have here, environmental and anthropogenic activities. Ano ba yung impact natin as tayong mga tao sa environment natin? So that's the NIBRA. Yung iba dito yung ibang mga components do sa health, sa aquatics and agriculture, sa industry, sa energy and emerging technology and disaster risk, medyo nag-overlap sila doon sa first part natin. Yon. But you can also dwell or you can also go to these areas. Yon. Okay? So ngayon, let me share yung mga emerging fields of interest naman in technology. So we have here artificial intelligence. So medyo yung robotics natin, sila na yung mag-replace sa mga humans sa processing, sa mga industry. So automated na. So robots na, artificial intelligence. We have also data science, Internet of Things, yung virtual reality, edge computing, blockchain, yan, robotic process automation, and yung last one natin is yung creation ng mga intelligent apps. So may mga apps na like nag-create ng app for identification ng mga sakit ng mga halaman-halaman. So pag pinicturean mo siya, yung app na yon, it will give you an idea ano yung sakit ng inyong ng halaman at ano yung possible na remedies. Yon. So ngayon, yung ating R&D na priority areas ng DOST, medyo may dinagdag. So currently, this was added in March or February by our DOST secretary. So ito ay 15 additional areas of concern, especially for response in the current pandemic. At yung i-highlight ko dito, itong mga tatlo. So yung meron yung anti-dengue. So pwede kayong sana maka-come up kayo with anti-dengue drug. And also yung mga gamot for COVID-19. And also yung mga use ng AI, artificial intelligence and robotics for disaster management. Yon. So ito yung mga pressing issues lalo ngayong nagkaroon ng pandemic. And kaya yung number 15 is on virology and research studies. So ito yung sinasabi kanina ni Ma'am Angie na yung mga journals ay sobrang nag-boom nitong nagka-pandemic, especially for COVID-19 papers. So if you want to dwell on virology or viruses, pero mahirap yon kasi students pa lang kayo, you need a good laboratory setup for that. Pero ang point dito is in a matter of a year, sobrang nag-boom, nag-increase yung papers published for COVID-19. And also for other allied fields of specialization. Back na yung publication ay yung paper, pero ngayon within 60 days or less, mas napapublish na siya. Why? Kasi kailangan natin ng more information on how to combat this virus. Kasi every now and then may nababalitaan tayo nag-mutate si virus. So there's another study for that. Yung ganun. So ito, yung present ko kanina, yun ay mga research priority areas na na-establish na. So ang pwede niyong gawin as students, pwede kayong pumili doon and yun yung i-work out nyo as SIP. But there's also another way na paano mag-generate ng idea for SIP. So yung tinatawag ko siya na localization. So pag localization, ang tinitingnan mo is yung immediate environment mo, yung locality, yung community mo. So there must be a problem within your community na kailangan ma-address at kailangan siyang ma-solve. So we can do an SIP on that. Also, kapag may mga readily available materials tayo na hindi pinapansin, pwede natin siyang gawa ng study. Pwede rin yung mga agricultural wastes. Like ito ay yung pinagpresan na ng tubo. So ano bang pwedeng gawin pa dito sa tubo na yan? And also yung ating mga medicinal or native plants. So para mas ma-highlight yung kanilang medicinal property, ano pa kaya yung kanilang magagawa? Ano pa ba yung ibang purpose ng ating mga medicinal or native plants? Ito, pwede ko siyang ituro sa inyo, yung adaptation or localization. For example, nakakita kayo napakagandang research paper or journal article, tapos gusto niyo siyang i-adapt sa inyong setting. So meron kayong pwedeng mga gawin like this one. Yung usually may mga recommendations or problems na hindi na-address o na-solve yung previous researcher. So, bilang nabasa mo 'yan, pwede mo siyang paglaruan. Ikaw na yung this is the time na ikaw na yung gagawa ng solution for that particular problem. O kaya naman ay yung nabanggit ko kanina, pwede kayong gumamit ng mga local o native varieties. So ito turmeric ng Bangladesh. So pwede nating gamitin yung turmeric natin dito sa Pilipinas and maaring after nitong study nyo, pwede nyo pa siyang i-compare, di ba? So, madami kang magagawa. And also, pwede mo namang i-improve yung previous methodology. So, hindi to yung deliberate na pagkopya, pero ginagawan mo siya ng improvement. So, sa tingin mo, may something na mali doon sa nagawa ng previous researcher. So, you need to top it up. So, kailangan mo siyang ayusin o kailangan mo siyang i-rectify. So you add something that is novel o bago. And ito kasi nga, yung sinasabi ko kanina na cyclical yung ating research process or helical siya. Tuloy-tuloy siya. Hindi siya tumitigil. Okay? So, nakita ko ito sa internet naman, yung ating mga past winners. So pwede rin natin silang gamiting source of inspiration for doing your SIPs. So this is 2019, the Intel National Science and Technology Fair dito sa Pilipinas. So I will just enumerate 3 of them. So first one is si Mary Joyce Carla Buwan. So nanalo siya ng individual research in robotics and intelligent machines. So yung kanyang research ay ang inaddress niya dito na issue is yung kaingin system sa kanilang community. So ang ginawa niya ay nag-develop siya ng alerting device na kapag may nagpuputol na doon sa kagubatan, maririnig yun ng sensor. And di ba pag nagpuputol, may nare-release na CO2. So may sensor din for that. And pag na-sense yun ng ating sensor, ay maa-alert na yung locality na may nagpuputol, which is bawal. So, magandang inspiration tong nagawa ni Mary Joyce Carlabuan for robotics. Yon. The other one naman is for Nathaniel Reyes. So, ang nagawa naman niya is charcoal from cornstalk. So, yung mga di ba pag natapos ng anihan ng mais, tinatapo na lang yung katawan, yung stem nung corn. So, yung cornstalk na yon ginawa niyang charcoal. At hindi pa siya tumigil doon kasi ginamit niya yun to treat algal infestation. So, bakit? Kasi pag may algal infestation, nagkakaroon ng shellfish contamination yung mga tahong. So, in effect, mawawala ng kita yung mga fisher folks natin at yung mga may-ari ng mga fish ponds. So, napakagandang idea nung ginawa ni Nathaniel Reyes. Also, ito yung favorite ko. Nabalitaan ko talaga to. This one is for anti-diabetic and antioxidant property ng aratilis. Yung puno na may bungang kulay pula na minsan hindi natin pinapansin, meron pala siyang anti-diabetic na property. So, maaaring magtingin kayo ng mga halaman sa locality nyo na mayroon palang ganung property. So, you can do a research on that. So, allow me naman to share my experience. So, during high school, nag-adapt kami ng Indian agricultural technique at napakaganda ng result sa aming mga sitaw. Also, ito no, fourth year naman ako nung high school, nakapag-try naman ako mag-create ng biodegradable plastic. So, ang naging source of inspiration namin doon ay pandan. Napakadami kasi ng pandan. So, ang ginawa namin, nag-isolate ako ng starch noon. Then, yun yung starch na isolate, yun yung ginamit for the creation of your biodegradable plastic. And now that I'm currently taking my master's, so ito na yung mga nadagdag na interest ko. So, nanotechnology, protein chem, phytochemicals, and cellulose. So, sana dito sa slide na to ay medyo ma-entice ko kayo na you go to nanotechnology kasi napakaganda, napaka-interesting ng nanotechnology. This is what I'm supposed to do in my thesis, in my master's. Yon. So when we say nanotechnology, this actually dwells dun sa nanoscale. So when you say nanoscale, ito yung mga 10 to the negative 9 meter. So napakaliliit nila. Pero hindi sa sobrang liit nila, madami silang nagagawang application. So from energy, from electronics, from agriculture, cosmetics, biotechnology, and textile. So, may maaari akong i-share sa inyo this one. I have an experience of synthesizing gold nanoparticles. So, from gold, nakapag-synthesize ako ng very small na nanoscale. So, meron yung gold mo, pwede siyang maging iba't ibang shapes, like that. Pero yung experience kong gawin is nanoparticle, yung bilog siya. So this comes in different shapes and sizes, and yung nanoparticle na nagawa mo, pwede mo siyang i-functionalize, pwede mo siyang kabitan yung surface ng mga kung ano-anong mga substances. So, at yung nanoparticle mo, pwede mo rin siyang i-coat. So parang may protection siya. So bakit ginagawa yung functionalization o paglalagay ng mga DNA, amino acid, ng mga proteins? Kasi yung nagawa ko sa experience ko ay pwede natin gamitin kasi itong mga nanoparticle in many different medical applications. So like gene and drug delivery, cancer therapy, biosensing, and bioimaging. And so far, ang nagagawa ko pa lang is on biosensing. Also, I have an experience on doing silver nanoparticles, and si silver nanoparticles, napakadami din ng kanyang nagagawang applications. So ito yung iba't ibang kulay ng nanoparticles na iba-iba yung sizes niya. So usually kasi ang nanoparticles ay nag-range from 1 nanometer to 100 nanometer. So dapat dun sa range lang na yun ang mga nanoparticles. So yung plan ko sana in my thesis, in my master's, is to use proteins na siya yung mag-cause nung formation ng aking mga nanoparticles. And before the pandemic, nakagawa pa ako ng isang research na gumamit ako ng isang tree, hindi ko siya i-share yung identity niya, pero plant extract yung ginamit ko sa kanya. So yung plant extract kasi madami siyang components. And yung mga plant extracts na yan, pwede rin silang tumulong para magkaroon ka ng bioreduction from your silver ions or gold ions, magiging elemental sila and nanoscale sila. So ito, pag nagawa nyo ito, kung ma-entice ko kayo, ay pwede nyo siyang gamitin or pwede nyo gawin for further studies and application. So ito, medyo tinanggal ko lang yung mga some parts kasi my advisor and I are planning to publish this. So meron lang kaming kulang na part pero napaka fruitful nung experience na to kasi I was able to present this in Cebu in Philippine Chemistry Congress, and yung pinaka ultimate na experience is when I presented this in Korea. So I presented this in Seoul, Korea. So yun yung una kong labas ng bansa, and conference agad yung aking napuntahan. So ngayon, ano ba yung mga challenges na kinakaharap natin? We are now under a pandemic. So medyo we already transitioned to online classes. Yung mga instructional labs and research labs ay sarado pa ngayon, at yung mga klase nga, schools ay sarado din. So the question now is how to conduct your SIP. So medyo additional lang ito sa talk ko for this morning. So I'm advocating home-based experiment. So when you say home-based experiment, dahil nga hindi tayo makapasok sa laboratories, gumagamit tayo ng mga alternative mga materials. For example, instead of beakers, we use plastic cups, and instead of mga lab-grade na mga reagents, you use the reagents that are readily available in your house. So, ano lang yung mga pros and cons ng paggamit nito? So, of course, yung impact na is magagawa nyo pa rin yung experiment nyo. Yun lang, may mga potential problems. So, yung iba kasi dito ay mga hazardous pa din. So, meron siyang adverse effect dun sa gagamit. And, yung natanong kanina is paano po yung magkukonduct kami ng experiment na wala kami ng mga proper materials. So, maaring dito na kayong magkaroon ng divide sa qualitative and quantitative. So, as much as possible kasi maganda na quantitative yung data ninyo. Pero kung qualitative lang naman ang ma-generate nyo, it's also okay. Right? It's part of learning, di ba? So, ano yung possible na solution na may offer ko is we can ask your schools for some support, like for lending of equipment or materials or some reagents. And yun na lang, teachers will be the ones to supervise. Kasi kailangan ng supervision pag nagagawa ng mga researches. Okay. So ito, nakita ko to sa internet din. I also have an experience no college na nakagamit naman ako ng mga sensors. So this is called Arduino. So yung experience namin sa klase, pinagamit kami ng professor ko ng this gamit namin siya sa isang farm. So dinidetect yung ammonia levels kasi 'di ba pag nag-excrete yung ating mga animals, yung mga farm animals natin, nag-excrete yan ng mataas na ammonia. So pwede din yung ma-detect. So ito yung sasagot nung yun na paano yung data collection. So one missing field din yung Arduino. Yan. So you can do Arduino. And napakamahal niya dati, pero ngayon napaka-available na niya in Lazada. I'm not pushing, pero yung market ngayon ni Arduino available na siya. So, also, isa pang solution na pwede niyong gawin ay pwede kayong humanap ng mga magpa-fund sa inyong mga researches. So, kaya anchored on POST kasi sila yung nagbibigay ng areas researches. At kung mag-a-apply kayo, pwede rin kayo mabigyan ng funding. So, mas maganda yung results niyo. So, this one is PCHRD and the other one for SF. So, PCRD. Yun. So, nagbibigay ng grants ang government agencies if you're willing to do some research. So, for my conclusion or my sum of all, these SAPs are conceptualized, designed, and conducted having to advance our SNP, science and technology here in the Philippines. So there are already existing priority areas in research from gawing source of inspiration in yung mga topics, and yung sinabing idea on mission is made in generating ideas for your SIPs. And home-based labs can be an alternative mga nagsarang mga laboratories and research institutions. And while we are advancing science and technology by using your scientific mindset, you act like a scientist, we should also have this mindset that cares for others, our one and only planet, and we call that your citizen mindset and planet mindset. So to end my talk for this morning, allow me to quote Marie Curie. So she said, "Nothing in life to be feared. It is only to be understood. Now is the time to understand more so that we may fear less." And I think this quotation of Marie Curie encapsulates yung idea ng paggawa, pag-conduct, and share ng mga results nyo in your FPs. With that po ang aking mga nagamit, mga resources, mga photo FS, photo credits. And with that, thank you very much, and I am now ready to entertain some questions. Thank you very much po.
Thank you very much, sir. May I add nga pala? He's currently taking his master's degree as a DOST scholar. Kita niyo yon? Ang ating mga speakers ay talaga namang napakahusay. Diba? So now, we are entertaining your questions. Go na. Chat nyo na yan. Huwag na kayong mahiya. Or you can unmute your mic. Hello? Nag-iisip pa yan, mga yan.
Nag-isip pa sila.
Hello? May lalabas din yan. Hello, we're waiting. Yan, eto na. Tanong ko lang po tungkol po sa bioplastics. Okay?
Hello po.
Yan.
Hi.
So, meron po kasi kaming research ngayon. So, about bioplastics po. So, ang amin pong bioplastics po ay gelatin po and other materials po. So, nakapag-observe na rin po kami, nakapagawa na po kami experimentations. Ayos naman po, pero kailangan lang po namin ng advice po na kung paano pa po ito mapapaganda po.
Okay. So, I have mentioned earlier that yung ginamit namin na plant material dun sa high school, yung experience ko sa high school is pandan. So, unang ginawa muna namin is to establish the starch content nung plant material. Kasi, mahirap kasi mag-proceed with your production of bioplastic na in massive scale na kakaunti yung starting material mo. So I will recommend that you look for a plant material or plant species na mataas-taas yung kanyang starch material. Yon.
Okay po, thank you po.
Thank you.
Permission to speak po.
Yan. Yes.
Hello.
Good morning po. Bali po, yung po mga students namin ay nag-inclined na rin po sila sa Arduino. Actually po, may project po kami dito sa senior high school with regards to the, yung po sa concern po is sa tubig. Ay, ano po kayo mabibigyan yung advice, for example, with regards to the collection of microplastics? Ano po kaya yung mga sizes talaga na na talagang magandang i-collect at ano po yung mga ways on how to collect using our robotics po.
Hmm. Medyo, yung kasi I'll be honest, microplastic medyo malayo siyang field sa akin. Pero I will try my best to answer that. Yung sa detection ng microplastic, kasi I have a friend in the graduate school din in PLB. She is doing a microplastic studies din. Ang natingnan naman niya is asin. So, napakarampant na kasi ng yung microplastic in our aquatic bodies of water, mga bodies of water natin. So, ang na-share na sa akin dati is, ang nagawa niya is microscopy. Kasi may mga microplastic na kita pa rin yung, kasi di ba micro siya. So, nasa 10 to the 6 meter siya. So, mga micron level. So, nakikita pa siya. Pero kung gagamit ng sensor, kasi ang maganda kasi technique for microplastics based on what I know and based on the na share sa akin ng friend ko is paggamit din ng mga UV, yung mga spectrophotometry methods, yung mga high-end na spektro. Kasi, di ba ang ating mga microplastics ay, ano pa rin yun mga carbon-containing compounds. So, para ma-determine mo kung anong klaseng starting material. Kasi we have yung PEP bottles, yung mga iba't ibang klase. So, in the ocean kasi, in the bodies of water, usually naghahalo-halo na sila. So, medyo hindi mo na siya madidistinguish kung sino. 'Di ba? Yun po. Pero sa Arduino, wala pa akong makitang link with Arduino and microplastics.
Salamat po.
Yeah.
Challenging yun.
Next question po. Once na po kami nagawa ng study concerned with bioremediation po at curious po ako, ano po kaya ang pinaka-important na parameters na i-measure po para mas ma-analyze ang potability ng water para po ma-consider siya as usable?
Okay, so mayroon tayo ng mga tinatawag na mga tester. So one of which is yung pwedeng gamitin ay TDS sensors, mga nabibili lang sa Lazada, nakabili ako. So tinry ko siyang gamitin and nakaka-detect naman siya in ppm level. Pero kung talagang ang concern mo is mga heavy metals din, maganda din na gumamit ka ng mga spectrophotometric na mga techniques for quantification. So dapat meron ka ng parang calibration curve, tapos i-determine mo kung ilan yung component, ilan yung quantity ng iyong heavy metal doon sa iyong water sample. Yun.
Next. Question po related sa biotechnology. How can we push biotech innovations and changes po if the people are the ones resistant or hesitant to it? Thank you.
Can you repeat the question, Lay?
Okay, ito po. Biotechnology. How can we push biotech innovations and changes po if the people are the ones resistant or hesitant to it?
Okay, so ang magandang gawin natin doon is ma-persuade talaga natin sila doon sa mga kumbaga wini-weigh natin yung pros and cons, and usually ang research naman is conducted not to harm us but to contribute something greater, something good in our community. And yun ang laging spirit ng research. Wala naman siguro nag-research na ang gusto ay makasira, di ba? Di ba? So yon, dapat ma-convey natin ng ayos yung message that that yung mga benefits will outweigh the problems or risk. Yon. And usually scientists will make sure that yung benefits will be totally 100%. Yun. Diba?
Okay. Meron tayong next question. Ano nga po uli yung sensor na nabanggit?
Arduino.
Okay,
Arduino.
got it. Okay.
May
Meron pa po
Arduino na
bang...
may Arduino nga din na pH meter style siya, pero yun nga gumagamit siya ng more of physics pa rin. Yun. So, mayroong doon sa nakita kong Arduino sa Lazada, meron siyang yung commercial na available na pH meter, tapos yung pH meter na Arduino. So, pwede siyang gamitin na para ma-check nyo din yung differences nung sensing capabilities nung pH meter na nabibili lang at yung Arduino, which one is better in sensing. Yon.
Yeah, thank you very much, sir. Meron pa po ba tayong hahabol? Questions? Chance nyo na to. Okay. Wala na po bang hahabol? Hello? Pwede po kayong mag-unmute? Yan. Isang sensor lang po ba pwede sa Arduino?
Actually, madami. May mga kits yon. Madaming Arduino kits ang available po. Yon. May ammonia sensor, CO2 sensor, may pH sensor. Ang dami na pong available na sensors. At yun nga yung pwede nyo magamit din as alternative dun sa mga equipment natin na wala tayo ngayon kasi sarado ang mga research laboratories natin. Yun po.
Ayan, mukhang wala nang magtatanong. So, thank you very much, Sir Geoffrey S. de los Reyes.